Okay, so this is the pencil where we left off. I think the next step was to go right into to create the tip of the pencil, right? So we've built this shaft, and let's start then to keep our model organized. Let's make a new geometric set and start working on the tip construction. So if this construction geometric set is activated, and that's by right-click, define in work object, you can press your geometric set button up here, new geometric set, and it'll drop a new one down below. I'm gonna rename this tip construction. So that's right click and properties. Tip underscore construction. Let's also rename this construction set. Let's rename this shaft construction. So right click on construction, feature name, shaft underscore construction. Can you guys see? Is that easier to see? And we're going to make one more geometric set. One more geometric set, and this one we're just going to call construction. What I want to do is I'm going to make one global construction geometric set and nest the others inside of that. Now we're going to move the shaft and tip construction into construction. So select those two geometric sets, holding down Control. Right click, selected objects, change geometric set. You get this little dialog box, and I want to just select construction, and it's going to ask me, do you want to put it before construction or inside at the last position? If you select no, it's going to drop it inside that geometric set, so press no. And OK. There, so now I've got construction, shaft construction, tip construction.
Yeah.
Which one did you, where did you get stuck? Moving them?
You select.
Okay. Select these two. Right click. Selected objects. Change geometrical set. And this works with any geometry, reordering geometry from one geometric set to another. So when you click on that, you don't have to click anything, just click on the geometrical set. And you want to say no. No, I want to put this selection inside the geometrical set in the last position. So destination is construction, before last position. Press OK, and it's moved into that geometric set. Yeah? Is anybody not getting it to move? You're not? Can you help here, Craig?
Yeah, I think when I'm setting up the geometrical set, it comes up with like a box in the bottom that says it's a geometrical, and it has named father. It's like name and father is feel like choosing, I guess, what it goes under. Instead of
Select the cancel. Little down arrow and the swap again.
Oh, okay. There you go. Okay.
There are other ways to make geometrical sets inside of other geometrical sets. This is just the way I tend to normally do it. And this is good practice for moving stuff around inside the tree. So we've got our PW pencil, construction, shaft construction, and tip construction. Let's right-click on tip construction and define and work object. Now that's the active geometric set. Does everybody remember how to rotate? Yeah.
If my tip construction and shaft construction both branch from the construction folder to not the tip construction from the shaft construction, is that okay? Does that make any sense? No. So both of these branch from construction. For yours, you have the tip branching from shaft.
It's not branching from shaft, it's just a little plus sign. This leads into an important organizational topic, though. When I set up my model, I like information to flow down. So the higher, because modeling in digital project, I'll say it over and over, it's about modeling relationships between geometry. And there's a hierarchy between geometry. So there's parents and children. The parents always kind of dictate what the children will do. I like to put the children up high, as high in the tree as possible, and let their children trickle down through the tree. So here, everything that's inside this pencil geometric set is based on the inputs. When we start modeling tip construction, everything inside tip construction is going to be based on shaft construction, which is based on inputs. As we start going down and building some more surfaces and like the eraser and the eraser clip or whatever you want to call it, all that stuff is going to be based on the tip construction, shaft construction, and inputs. So the inputs trickle down through, and the hierarchy of geometry is represented in the tree structure and the nesting of geometric sets. Okay? So if you have tip construction above shaft construction, it'll work fine.
I changed it.
You can change it. I'm glad you did. It's not going to be a... Once you get into really big models and you've got 50 geometric sets and you've got stuff up here that's referencing stuff down here, that's referencing stuff over here, jumping back and forth between the tree gets to be a real pain. So if you know that stuff up here is always going to be, you're always going to be kind of filtering down into the model, it gets easier.
So,
just easier to organize.
If we made construction as a geometrical set, what other geometrical sets would you make besides construction?
Generally, it'll come as the model develops. You'll start making new geometric sets. You start reorganizing geometrical sets. You'll start realizing, well, this geometry, it's better if it's up here rather than down here.
So
we could.
construction was purposely like very general.
It was very general to begin with, but now we've realized, well, shaft construction, tip construction, those are all kind of subsets of construction. So we'll just nest them under construction. And while I was finishing the other pencil, I realized I wanted to isolate the control geometry that drove the rotation of the pencil. So I even made a different geometrical set for control geometry that I pulled out even further. And we could do that now even. I saved it for later. Or I came later in the process when I was finishing the model earlier. But we could just as easily do it now. But we'll save it for later. We'll save it for later. So we've got tip construction. And if I remember right, in our geometrical set, or in our sketch, we have 2 output profiles. Does everybody have 2 output profiles? I remember doing the circle at the very end of class last time. Did everybody get the circle in there? Yeah? You did not get the circle?
Yeah, I don't think we have.
You just have one?
Yeah,
Yeah, I only have one.
You only have one? Okay. Then I'll delete that circle and we'll make a new one.
oh no, we have.
Okay, so everybody double click on the sketch. And you probably zoomed in, reframed parallel to the sketch plane, perpendicular to the sketch plane. So this is where we're going to make the circle for the revolve. We could have made the circle, we have all the support geometry we need to make the circle outside of the sketch. But we're doing it in the sketch. Just because. Tell you what, we'll do it in the sketch and then we'll make the circle outside of the sketch too. So just so we know of both ways to make a circle. So here's the circle command. We've got a couple methods of making a circle. We're going to do it by center and radius. So select the center of the sketch and pull it out. And remember, if it's going to try to give you constraints, it's going to try to make constraints automatically for you. Try to avoid it making any constraints. I think it was Alt. Alt was the way to do that. Nope, it's Shift. Holding Shift will keep it from automatically making any constraints. I don't remember exactly how we constrained the sketch, this circle last time, but if we want, we can select that circle. Does everybody have the circle? No? It's, can you see that button from way back here? The circle? Press that. And then you do want to snap to the center. So don't hold down Shift yet, but allow it to make the constraint to the center. You'll get that blue filled double circle symbol. That one. So click once and then drag out. And see, it's trying to make constraints for me. But if you hold down Shift, it'll keep it from making constraints. A little red circle.
Yeah, it looks like a 2 on
Oh, but you already made the circle.
We do circle and then click in the middle. Or do you hold the click?
That's what happened. Okay, first, I think we should make the circle right. What's the difference between
Yeah, it's because we already have 2. It must be because we already have 2. But it doesn't make sense that we could have 2 circles. I'm just going to
How do you get the windows back? Right click over in this gray silver bar, and you want sketch tools and user selection feature. You don't really need user selection feature, but sketch tools are pretty important. And then make sure these are not orange. These two buttons are not orange, because that's going to snap to a grid. That's going to turn the grid off so you're not looking at the grid, and it's going to make it so you're not snapping to the grid.
If we already had profile 2, then it won't let us make that circle.
It'll let you make a circle. It's just going to give it a different name.
Okay.
Okay.
Do you already have a circle? If you have
yes, I
profile
do.
2, you should. Yeah, you have a circle.
Okay.
So what was the?
I
I'm just looking to see what constraint we used for that. That's okay. All right, so now does shift work? If you hold shift, now you don't get the constraints? So let's select one of the vertices of our hexagon, any vertex you like, and then pressing Control, select the circle. Go up to Constraints Defined in Dialog Box button. And we're going to make these two coincidence constrained.
Sorry, you say go to what option?
This one that's constraints in dialog box. Constraints defined in dialog box. And if you constrain them by coincidence, coincidence is saying these two are going to touch always. You could also constrain them by distance and set the distance to 0. We could constrain them by radius and diameter, but the thing about radius and diameter is you can't set it by a formula. Remember, we did a formula last time linking the parameter of the point on the line to the ratio parameter. So once you constrain it by coincidence, press OK. And it turned green.
Can I ask you a really simple question?
Absolutely.
What is the difference between green line and
Orange?
Yeah.
Orange or red?
just orange? I don't have them up.
Oh, okay.
I've seen
Like if you select I think if you select the space, it'll turn the outline of it orange.
It will turn red if you over constrain it. It will. You can project geometry into your sketch. So if we take this line and we want to project it into this sketch, it's going to be, I think it's going to be white. No, it's yellow. Orange, I think, is select. Yeah. There, it's orange and it's selected. If you make a construction.
So like, will a finished line always look orange? Or I mean, sorry, green?
In a sketch, yes.
Sketch? Okay.
In a sketch, it's not finished. A fully constrained line is always going to be green. A normal line is just going to be white. And an over-constrained line is going to be purple or red.
Okay.
Orange in a sketch means it's construction, orange or dashed. So does everybody have this circle? You can make it a profile by pressing this button, profile feature. And it's going to give us the circle as an output. If you didn't already have a profile 2, it's going to give you profile 2. I already had one, so it's giving me profile.3. Sure, sure. I will say though, if you're going to go through the task of renaming anything, you might as well give it a proper name like circle.
But can I just change it up here?
You can change it here in the name, yeah, not profile 2. But if you're going to name something, I would go right ahead and call it circle profile.
Okay.
You can give it a color if you wanted to. I'm just going to leave it white because that's default, and I never really deal with or change colors outside of coming out of sketches. Yeah.
How'd you export the profile?
This right here, profile feature, output. I think I might say output behind that window.
What's the difference? Like, I see when if I click the circle again, it
Mhm.
leaves input, it leaves the category of input geometry, and it's just an output geometry. What's the difference between the two?
Input geometry is the geometry coming from the sketch.
Okay.
So like when we did the hexagon has 6 lines. It's composed of 6 lines. And so I remember when we made that hexagon, we selected one of the lines and said output profile, and it said this one line is the input, but because it's connected to all these other lines, the output is this entire profile.
Okay.
And so when you access that profile from outside of the sketch, you're going to get those 6 lines as one closed curve. The other option is to output one line, output feature, and in that case, we could output each of these 6 lines individually. So I'm going to hit OK to output my circle. If I select this line and just output feature, it dropped outline or output 1. It didn't give me that dialog box, it just gave me a line output. If I select that same line and say output profile, that line as input is giving me all of those outputs as one curve, one joined curve.
After we clicked OK, another profile definition dialog box.
Which one?
Double click on a command, it will think you want to do it forever.
Ah, right.
Keep bringing up the box until you can. So
Good point. Yeah, that's actually, just hit escape. If you want to make 6 intersections because you've got 4 lines, or 4 intersections because you have 4 lines, if you double click intersect, you can just hit line, line. It'll make an intersect and give you the dialog box again. Line, line, make the intersect, give you a dialog box. If you want to make a bunch of points, just double click point and it'll give you the option to make all kinds of points. So we all have an output circle? Yeah? Okay. Now let's exit Workbench. And it's jagged right now, which is kind of confusing. We don't know which one is the circle, which one is the hexagon. That's one reason why it's nice to name it. Maybe you'd give it a different color, so the circle is one color and the hexagon is another. I think if we hit F10 and go into settings, we can change the display so that it shows more exact circle. I'll let you play around with that. I'm not gonna.
Is there any reason why it does that? Why it defaults to a second?
Performance issues. If you have a million circles in your model, it's gonna just make it really slow to rotate. So this is one way to make a circle. If we let's everybody hide this shaft. So that was the extrude.1. You can either select it and hit Control H, or you can right click and go to hide show, or you can right click and just press H. One thing I'm not such a big fan of about sketches is if we want to hide the sketch, you would think you can just hide that sketch in the tree, but when you go to right click and hide, it hides the sketch, but it doesn't hide the output profiles. So if you want to hide those profiles for now while we make a different circle, you have to actually hide the outputs. You can if you want, I'm not going to bother, we'll work around it. So if we want to make a circle, a normal circle, like a constructed circle in the normal modeling environment, You press the circle button over here. It's just like any other geometry definition window. We can select how we want to make that circle, and a lot of these ways of making the circle are similar to how you would do it in the sketcher. You just have to have more geometry defined in the model. When you create geometry in the sketcher, it creates a lot of stuff with it on the side. Like when we made the hexagon, it made all those constraints and those circles and stuff. If we wanted to make it on our own, we would have had to, or in the model space, we would have had to make points and lines and circles and all that other stuff. If we do it here, we're going to do it the same way by center and radius. The center is easy to define. That's the point dot 3. The support is the plane. In the sketcher, we didn't have to define a plane because it's already constrained to a plane, because we used the plane as a support to create the sketch. Here we need to define the support, and that support is going to be our plane that we used for the sketch. And so now we have a couple of options. We can change the angle that we're going to make. So right now we're making an arc where we want to make a circle, but the arc is the same thing as a circle, just with an angle attached to it. If you want to make a full circle, you can either you can go into this field and say I want to end at 360. I've completed my circle, or you can, the more proper way would be to press the whole circle button. And then we've got our radius here. If we want to link our radius to the dimension of the hexagon, we would need to make a parameter. That's what we would have to do. So the hexagon, we didn't make a parameter. We just constrained it to 0.25 inches because that's what looked about right for the pencil. Let's say we didn't know what that pencil size was going to be. Let's just say OK with circle definition. Whatever your radius is, make it really big so that it's obviously not right. And let's make a new parameter. New parameters are in the formula button. Did everybody get the circle? You think so? You think so, or no? You do?
My circle still came out as
Your circle.
Can you show the visualization? I missed that.
F10, display performance. And you might as well change some of these. Let's see if that did anything for me. Oh, that fixed it. Nice for me. Did you guys see what I did? F10, 3D to proportional. Okay. So does everybody have this? And the pencil, or the circle, You can make it as big as you want it. Just make it big. Good. So can we make a formula or make a parameter? So we're going to make a parameter by clicking on the formula button. And we want it of type length. So go to that drop-down menu, type length, new parameter. And let's just name it in this window. Did everybody press new parameter? So now we've got length.1 here. Let's call this pencil diameter. And then let's make this 0.25. And press enter. Good, and then press OK. Scroll up, and now we should have pencil diameter 0.25 in here. Yeah? Now double click on the circle again. Right click in this value. It says radius right now, but we're going to change it later. Right click in the radius value. Edit formula. And select pencil diameter in the tree. Does everybody have that window? No? Did you edit formula in the circle radius value field?
Maybe. Expand your parameters.
Oh, that was just like a visual. Display. And then once.
I got all my stuff in the wrong spot.
I think that's what we were confused about last time. It's like, it was technically a circle, but it was split components. The pencil diameter is 0 inches. Which is giant. I think
It should put it in there by default. So if you have it, it should be there. Press OK. Just hit OK. Now change it there. Right click.
Double.
Oh yeah, that makes sense when I properties. So yeah,
I don't know if it's supposed to change it.
why did we make a second diameter?
Did yours change the diameter?
Yeah.
Oh, okay, there it is.
And press OK. But now, see, I said it was the radius. We want the diameter. So click on the radius, and it will automatically switch it to diameter. But we lost our formula. I didn't know that was going to happen. So now we have to right-click, edit formula, select the parameter again, press OK, and so we had to relink it. Good practice.
Why did we have to make a parameter to do that?
Because we're going to tie that to the hexagon. We didn't make a parameter of the hexagon, and we want both of them to change. When one changes, we want the other to change. If we didn't do it, and we started changing the size of the pencil because it's a design parameter, the model wouldn't behave the way we want it to. Because something would change and something else wouldn't. We want it all to be linked to the same global drivers.
For whatever reason, mine isn't.
There is an option in your settings that will not make functions. Okay, so everybody has a formula. Click OK. We need to go back in the sketch and constrain the sketch to that parameter, or link it to that parameter. So double click. Remember we constrained our sketch. We already made that dimension, but we want to link it to the parameter now. So double click on the 0.25. The value is 0.25. We hard coded it before. Now we want it to be referenced to the parameter, so the circle and the hexagon will change at the same time. So right click, edit formula, pencil diameter. OK. Now we've got a little formula button and it's grayed out, so it's linked. It's good. Press OK and exit the sketch. Now we've got a couple circles inside of the hexagon. You guys get that? Yeah. Let me see if I can undo out of that. Whoops.
So once we change that parameter, it changes everything.
Yeah, so now that parameter is going to globally change everything. Let's see, is this connected? Okay. So double click on the sketch. You're inside the sketch now, and you should have this hexagon constrained by dimension. If you double click on that dimension, there's a value field, and now you right click in that value, edit formula, click on the parameter up here again, and press OK. Does that work? Okay. Now if we exit the sketch and we change the parameter, just change it to 0.5. Everything moves with it. If let's say we don't want the model to update. Right now we're getting live updates. Whenever we change one parameter, it's rippling through the model, causing an update loop to happen. Let's say you have a really big model and you want to change a bunch of parameters before you update, because updating one parameter takes 3 minutes to update the entire model. You can turn off the updates by a button that's hidden right now because of my low screen resolution. Here it is. Manual update mode. If you select manual update mode, now you can do whatever you want in your model and nothing's going to update. We can change the parameter to 0.5 and change the pencil tip to 0.25. You can see stuff is turning red, means it needs to be updated, but none of those changes happen automatically until we press the update button. So if we can press the update geometry button, or we can go up to the part or to specific pieces of geometry and locally update them. Let's say I just want to update my hidden extrude. I can right click and local update. There, now well, okay, it updated my extrude and all the geometry that needed to update in order to get that to update. Right? Some people like to work in the manual update mode. I prefer to work in the live, always updating mode. So when it's orange, this button is orange, it's manual update. When it's not orange, it's going to live update. And if you want it to update, you can just hit that update tools update button. I'm going to close that window because I never use it. Well, rarely use it. Okay, so I'm going to go back and put those to where they were, 0.25 and 0.1. So everybody has this right here. Let's make that revolution surface now. So I made that circle in tip construction. We only made that circle so you guys could see how another way to make a circle. I don't want to work with that circle. I'm going to work with the sketch circle. So let's just hide that circle and forget about it. So the first thing we need, we already have our revolution axes. That's the shaft line. Line dot 1 in this case. But we need to make the profile that we're going to revolve around that line so we can make basically a cone. So the first thing we need is the tip of the line to make the cone. Let's show line dot 1. Right click, hide show, or just H. And now we're going to put a point on this line that's going to represent the tip of the point, the apex of the cone. So go to the point button. We can make it on plane, but we want to make it on the line. So you can either go to on curve or select the line, and it will automatically infer that we're going to put this on the line. And this is what it should be doing. It's giving us, by default, a distance on the curve, a length along the curve. And so there's many different ways we can create this point. We're going to create it one way so I can show you how to make a rule. And a rule is a very powerful concept in Digital Project that allows you to evaluate if-then statements or measure distance, evaluate the model, and decide on a certain outcome. This is one very powerful aspect of parametric modeling, where you allow the model to make decisions for you. You program a decision-making process into the model so it can evaluate it and produce an outcome. First, we need to make this point a certain way so that we get the right apex of the cone. So we're going to leave it at distance on curve, but we want to reference our sketch point. So go down to reference, point. So this default extremity is highlighted. Select inside that field, and then select point.3. It's probably easiest to select it out of the tree here. And so now the length along the curve is referencing a length from that point. So now as that point moves, as point.3 moves, the new point, point.5 that we're creating, is going to move with point.3 always a certain distance from that point along the curve. Because the curve could be doing this, so you're going to get a distance along a curve, not a linear distance. If you wanted a linear distance, you could do a distance along direction and then define a direction. But
So is this how essentially we make that pencil like sharp and like sharp?
yes, and the rule is going to help us make it from a sharp pencil to a flat pencil, to not sharpened at all. So we've got distance on curve. We want to flip it so that it's pointing down, so that it's below the opposite direction. So hit reverse direction. And let's make it 0.4. 0.4 distance. And then you can preview that. Preview, so that's where that point, you see the point isn't even on the line anymore. For me it's not. It might be on the line for you. For me it's not. Press preview down here. Does everybody have that? And press OK. Now, if we change that pencil tip t value, parameter value, we can change it to 0. And that point is still 0.4 inches away from our point dot 3. Change it to 0.25. It's still not on the line, but it's still 0.4 inches away. So we've hard-coded that relationship from one point to the other, always on the line. Now we want the ruling line for the cone, so we need to put a point on our circle profile. So make another point. Remember, we just made it by curve. Digital Project remembered that we're making a point on a curve. Select that circle, and we can put it really anywhere. We can put it anywhere along this curve. Yes. If you just select it in the tree, it's going to automatically go to that profile curve. If you want to find it in the tree, you can also select it here. If you wanted, even you could use this circle, but since I hid it, I don't want to use that one. And I'm just going to make it by ratio on curve, and I'm going to put it at 0. You see, it automatically gave a reference point as an extremum. I won't get into extremums right now, but on how to make it. But an extremum is basically a high point on a curve along a direction, or on a surface along a direction. If you have a surface doing this, and you have a plane down here, and you take an extremum of this surface using that plane, and the direction of that plane is up here, it's going to give you a high point on that surface. If you have a line in this direction, and you do an extremum of using this plane, given that direction, it's going to give you that point. If you do a reverse, it's going to give you that point. So that's kind of the idea of extremums. And extremums are underneath the point tool. So that's what everybody has that. Press OK. So you've got a point, and now we're going to make a line. Now that we're out of that command, here's the extremum. Press the little down arrow. That's how you make an extremum. You can play with that one later. So everybody has a point and a point. We're going to make a line. A line by points. So line definition, point, point. Here's the line button. Point 1, point 2. And that's it. Press OK. Now we can revolve. Does everybody have the line? Revolve is under translate. No, it's not. Revolve is under extrude. Yes, it is. So there's the extrude button over here. Yours is docked probably on the toolbar, docked over here somewhere. Click the little black down arrow button, and there's revolve. So revolve is hidden under extrude. Yeah? Press revolve. Profile. The profile is our cone's ruling line. revolution axis is going to be our shaft line, center line. And there it is. Same with the circle. We can play with the angle if we wanted to. That's kind of cool. We'll just, whoops, set that at 360 and press OK. Anybody have troubles with the circle or with the cone?
It only does half of it.
In the angle field, do you have 0 to 360, 0 to 180 probably?
Doesn't matter which way you do it, can it be angled to 0 and 1?
Probably there.
What is going to change is the direction of the cone, I think. Let's double click on it. Oh, that's the line. So let's check then. Let's check what this is an invert button, invert orientation. So surface direction matters, line direction matters. If we want to check the orientation of a surface, click on that invert orientation, select the cone, and reset initial. So the direction of my surface is pointing in. That's the normal of my cone. If I cancel this and I go from 0 to 360, it's still pointing in. Okay, so changing it doesn't matter. Okay, now we'll skip a we'll start splitting surfaces. We'll give this surfaces some color so we have something that looks like a pencil. And then we'll get into the rule on flat so we can flatten the end of it. So let's expand shaft, let's show the extrude. And I'm going to collapse everything down. So all I see is PW and construction. I'm going to make a surfaces geometric set. I like to separate construction from final surfaces because it's easy to hide construction and leave just the final surfaces visible. That's why I pulled out the control geometry also, so I could hide all the construction, leave the control geometry visible and the construction geometry visible in the finished file. So collapse it down, right-click on construction, define in work object, and make a new geometric set, and call it surfaces. When we rename it, it should automatically be the active geometric set now. And we're going to split the surfaces. We're going to split the shaft with this cone, and then we're going to split the cone with the shaft. So the split command is one thing you can do with the split command. If you select the surface and then press split, it's going to remember what side of the surface you selected and try to keep that side. So if you select the surface up here, you press split, and then you give the cone as your cutting object, it's going to remember what side you selected and try to keep that side. And then it's going to give you this kind of opaque, transparent piece of the surface that it's trimming off. Split is right here. It's underneath, there's join, and then there's split. One thing I would do between now and next class is to open up this file and just hover over every button and see what every button is called and what it can do. Even if you just hover over the button, see what name it is, click on it, check the definitions box, see how you create that geometry, just as a way to familiarize yourself with the different buttons, different commands, different ways to make or manipulate geometry.
And after split, what do you do?
So after split, the object that you selected, the extrude, should be up here, and this should be empty. If you select that cone, you should get revolute.1, revolution, the revolved surface, will go in the cutting elements, and then you'll get this transparent extrusion.
So,
Does everybody have that? Yours won't let you rotate? Middle click is your mouse button broken?
Because I did that.
If that happens, it'll take on the object.
Yeah. I guess he's hovering over it.
So press OK. And now we'll split the cone. We'll split the cone with. We can either split it with the split, or we can split it with the original extrude. Doesn't really matter. So select the cone, select split, select the split you just made. So now you've got as the cutting element. Yep. Press OK. And now we've got that pretty pencil tip. I did the reverse, yeah. I split my revolution surface with either the extrude or that split you just created. So if you expand surfaces, I've got split 1 and split 2. The initial split? Yep. So I selected extrude, and then I pressed the split button, and then I selected my revolution surface. And when you make a split, you'll notice that the original geometry doesn't go away, it just gets hidden. So my revolution surface, my cone, it's not gone, it's still there. It's just not visible anymore. So if I want, I can still go back and I can change that revolve. I can change the cone, I can move the cone, I can do whatever I want to the cone, and the split will update and react. That can cause problems, though, because if you make a change to the revolution surface and it no longer intersects the extruded surface, you're going to get an error. The split's not going to work, it's going to turn red, and Digital Project is going to give you a warning sign that says, your model's broken, fix it. This is what's broken. It's not going to tell you how to fix it, but it's going to tell you you need to fix it before it'll continue to work, to update. So if you want now, we can make the pencil look like a pencil. If you select split.1, oh, I don't have my graphics properties up here, so I don't know if you guys do. Do you guys have graphics properties? If you right click and go to graphics, graphic properties, now you can change the color. with the shaft, if you want to change the color of the shaft, if you select just that surface of the split surface and you change the color, it's only going to change the color of that face of that surface. But if you select it in the tree and you change the color, it will change the color of the entire surface. So I'll show that again. If I select the face of one of the facets of the surface, it's just changing that face of the surface. If I select the entire surface in the tree, then I change the color, the entire surface changes. Same for the cone. Select split that too and make it, was it tan? Yeah. There, so now we've got our little golf pencil. Little stubby golf pencil. If you want to make it taller, remember it's all based on the input geometry, so we can show the inputs. That point was on the plane. So if we change the distance between the offset plane and the original plane, our pencil will grow.
Wait, one more time?
So remember, inside the inputs, we based all of this off of 2 points on 2 planes.
Okay.
Well, we based all of the pencil on 2 points. But those 2 points were dependent on these 2 planes. So if we change the offset,
Did you double click on inputs?
I double click. I showed my inputs because they were hidden before, and I double clicked on that offset plane. So now we can make our pencil a bit longer, and I think that'll make it a little more proportional. I'm going to change that to 8 inches. And if you want, you can take a minute to spin your pencil.
I guess so. If they're not like, if they're not parallel, or I guess I don't know. Like
If your top point, yeah, if this one right here is way over here,
and then when you like move it, it'll like
goes way off in space like that.
Kinda, yeah.
Yeah, if you want to center it, you might need to get more on top,
Oh, okay.
more from a top view.
And then you actually just select point
You-
of the pencil and move it.
Yeah, you can double click on the point in the model space, or you can expand your inputs geometric set and double click on it in the tree.
Oh, okay.
And then click anywhere in space to start to move it around on that plane. Okay. Does everybody have the pencil? Does everybody make it orange? You didn't have to. That was for fun. Okay, so one thing I want to do is I want to make it so this pencil can get flat, like it's not been sharpened, like it's new. So if you change the pencil tip parameter from 0.25 to 0, we got an error. The split doesn't work anymore because it's not intersecting. So let's change it back to 0.1. Now let's try to get away from that. Let's make it so that we can have a flat pencil. Hide the inputs, and let's go back into tip construction. So right click on tip construction, define in work object, And now, just for clarity, I think it's important to name some geometry so that it's easy to call on it later. This point, point dot 5, I'm going to call this tip start point. So right click, properties, tip start point. I'm going to put a point on the shaft line at ratio 0, so right there, and at the very end of the line, at the very start of the line. So that's putting a point on curve, ratio of curve 0, and we should get it right there at the bottom. Does everybody get that? I'll do that again. Press the point button. Select the line. Do you have line.1 visible? If you don't, it's up in shaft construction. You can find it there. Ratio of curve length, 0. Preview, press preview, and it'll show you it's right there at the end, or the start. Press OK, so now we have a point here, and we have a point at the tip.
I don't think our points are actually inside.
Yeah. I don't think my line extended all the way out.
I don't know if that's a problem.
Where is it? Show me.
It's like a little bit inside. Just because this line doesn't extend all the way.
Okay, change your parameter, your pencil tip parameter to 0.5. There.
Okay.
Where did that go? That's point.7 for me. I want to name that let me just see, what did I call that in the other one? It was a good name. Shaft start point. So right click, properties, shaft start point.
That's point on curve.
Point on curve ratio 0 on line.1, or the shaft center line. Okay, so now we need to create a datum point that we're going to define by a rule. Does anybody have programming experience? Writing code?
Tiny bit.
Yeah, macro, Excel Mac would be, okay.
Yeah.
Okay, well then, you all will get to say after this that you've got experience writing code. Because we're going to write 8 lines of code. 6 of those lines are going to be curly brackets, though. Take shaft start point. Take shaft start point and Control C. Or right click and copy. Same difference. Right click on tip construction and paste. Okay? Now we've got two identical points. 2 identical points. I want to isolate that second one so that it's no longer a live point. It's going to become a dead point, no parametric relationship to any other geometry. It's going to be it's a dead point, a dead dumb point. So right click, go to shaft start point object, and isolate.
Copy it, so just copy that one second.
And now it's got now it's a little point with red parentheses around it. It's a dead point. The original shaft start point has a ratio property. This shaft start point now it's got nothing. It's dead. If you double click on it, it's a point explicit by Cartesian coordinates that you can't change. we can change the name of it. So we're going to call this now, we're going to right click on shaft start point, the dead one, properties, and call this shaft near point. Kind of zoom in a little bit and let's hide the surfaces. So right click on surfaces geometric set and hide it. We're going to hide that, all the contents of that geometric set. And let's so this is what everybody should have. Does everybody have this before we go to the next step? What we want to do is as this point moves along the line, we want to keep either this point, this tip start point, or shaft start point. We want to reference that point always, whichever one is closer. And so we're going to write a little if statement, an if-else statement, to define the shaft near point as the closer of those 2 points. So we're going to measure the distance, and we're going to define this dead point as one of those points. So to do that, we're going to go to our Knowledge Advisor workbench. So go up to Start, Project Standards, Knowledge Advisor. Everybody should have that. You guys will have more options. And so the workbench changed. One thing we haven't done a lot of actually is saving. Generally, before I get into any kind of code writing, I will save just because. So I'm going to do File, Save As. I'm going to call this Pencil Unfinished 2 because I don't want to save over the previous version that we've done. I'm personally keeping kind of a record of the progress in the class, so I know where we finished on task 1. Now I know where we will finish in task 2. So here's PW Pencil Unfinished 02. Save. Okay. Back to Knowledge Advisor. We're going to make a rule. And so there's different coding environments in Digital Project. And it's okay if I go over your head right now. I'm just going to kind of show you what's there and let you come back to it later as you progress in your model making. You'll hopefully come back and say, I wish I could do that. I remember I can do that. So inside Rules and Knowledge Advisor, you can define geometry. You can't create geometry, but you can define it. So I'm going to show you how to define geometry here, and then I'm going to show you the difference between defining and creating geometry in code in Digital Project. So here we're going to, do you all see this rule button? Click on that. And the rule editor, we're going to call this name of rule, we're going to say set near, set shaft near point. By default, we'll just let this drop. It's going to by default drop in our relations up here where we have our formulas. And that's okay. That's a fine place for it now. Press OK. And we get our rule editor window. So what do we want to do? We want to measure the distance between some points and define a piece of geometry based on that measurement. So we're going to use an if-else statement. I'm just going to type and you guys follow along, okay? So if, lowercase, all lowercase, syntax and capitalization is very important. If you look down in this window, I'm not going to explain this window in too much detail, but there's a dictionary here. And we want to perform a measure. So I scroll down to measures, and I see I can measure a distance between body to body, and it's going to return a length. I double click on that distance and it puts it right up in the window. Okay, I could type in distance, parenthesis, comma, and do it that way if I wanted to, but just to show you where this is, measures, distance, double click, and I get it right there. So the first measurement I want to make is I want to measure the distance between point 3 and my shaft start point, not shaft near point, shaft start point. So with my cursor right here between the parenthesis and the comma, I'm going to click point 3. I think I have to double click point 3. With my cursor now between the comma and the closing parenthesis, I'm going to measure the distance to shaft start point. So double click on that. So this is going to this function right here is going to return a value of a length, the length between those 2 points. I want to compare that length to another length. And I'm going to say less than. If this is less than, the distance, we're going to measure distance again. And again, we're going to measure from point 3. So double click, scroll over, and this time we're going to measure to my tip start point, and double click. So it's kind of hard to see, but it's if distance point.3 to shaft start point is less than the distance point.3 to the tip start point. Go to the very end of the statement, press enter, do curly bracket open, curly bracket, shift and square bracket, give you curly bracket. I'm going to say enter, enter, close the curly bracket, else, enter, open curly bracket, enter, enter, close curly bracket, enter. So now we've set up our if-else statement. You guys do coding in high school?
Yeah, we had to take like a basic coding class. It was terrible. I mean, I guess not.
Yeah, is this terrible?
First time it's applied since. So.
Okay. Ooh, we are running out of time. We are running out of time. Okay, so does everybody have that? Okay, so what we want to say is if that distance is less than the other distance, we want to define, select this shaft near point in the tree. We want that point to equal the shaft start point. Okay? Just, it's as easy as selecting it in the tree, pressing equals, and then selecting tip start point in the tree. Sorry, tip start point. Shaft near point equals tip start point. Otherwise, else, shaft near point equals the shaft start point. Good? If you press OK, I recommend you all do, you're going to get a little dialog box that says, do you want the relation to update? Yes, yes, yes. You want this thing, that means it's going to be live. Whenever an update is triggered in the model, this rule is going to run and redefine that geometry based on this evaluation. So press yes. And now, just like you linked a parameter to a formula, or a value to a formula, we've linked this point to a rule. But I must have gotten it backwards. Because it's not giving me, it's giving me a far point, not a near point. So that's easy. I'm just going to change my less than to greater than. Press OK. There we go. Is this working for everybody?
How did you edit the?
If you so if you want to edit that rule, you can double click on the object that's being defined by the rule, or you can go up in the tree and find that rule and double click on it. Is this working for everybody?
Got a syntax in there.
You got a syntax. That happens a lot. Does that work? Work?
What was it that you changed? Sorry.
I changed this, the less than to greater than, because I had talking and thinking doesn't always work for me. So press OK. And now we're going to relink this line to that point. Okay? So double click on the line, line.3. We're no longer going to connect it to tip start point. We're going to connect it to shaft near point. Okay? Did everybody do that? So now point.1 for your line.3 should be shaft near point, and it should end at point.6 or something like that. Your names might be a little different. Yeah? Press OK. And now change the pencil tip parameter to 0.02. You see what's happened? That point, the definition of that point changed from, it's no longer a tip start point, it's now shaft start point, because it's closer to point.3. And if you look at if you show your surfaces now, the tip has gotten a lot shorter. And now, actually, if we go to pencil tip 0, we don't get an error anymore because the surfaces, the split surfaces, are still intersecting. Before they weren't intersecting because the geometry wasn't working right together. But now that we've set it so that this line can flatten based on proximity to the sketch, it works. So that's one of the powers of parametric modeling. It's embedding these little tiny bits of logic that allows your model to make decisions based on rules that you define. Now we have 5 minutes left. I don't want to go too far over the deep end, but I do want to explain the difference between between a rule where you only define geometry, and something like a knowledge template where you can create geometry. We haven't talked about power copies either, but they are one of the biggest, most powerful parts of this software. If we wanted to replicate this pencil, it's very easy to create a power copy and instantiate this power copy all over the place because it's a little parametric element. If you want to build a funky adaptive facade based on environmental inputs, you can create this tiny component, this smart facade component, and replicate it. And if you've defined parameters clearly, like we have done, where we let our pencil make decisions, if you let your smart component make decisions based on environment, it can adapt and produce variation. Those little smart components are in this program called power copies. So you can make a little power copy and instantiate it all over your facade, and it could do different things based on its environment. Here's an example of 2 power copies that I built that put teeth on a curve. Okay, pretty simple, pretty straightforward. This power copy is built with a knowledge template. The other I have another power copy right here. Does teeth as well, but it's built with a rule. Here the rule, the code is the same. I won't go into all of the code, but this is the code that's driving that one curve. Okay? It's doing all kinds of stuff. Finding directions of the line, kind of offsetting from the line, measuring the line, putting perpendicular lines, rotating lines, tangent lines, closing lines, all to get that kind of tooth profile. But in the end, it's defining one curve object. Okay? So all that code, all that stuff going on there, just to define a curve. This is in the knowledge template knowledge-ware workbench, where it's a knowledge template, almost identical code, but in the end, it's creating geometry, not defining geometry. So here, if I delete this line and I delete this line, I can manually execute this little chunk of code, and it's going to generate that thing again. And I've got all of these parameters linked into that code to change, like the tooth height. Let's make it 3 inches. Let's execute this knowledge pattern. And I can set this knowledge pattern to execute automatically, so that whenever I change a parameter, this thing will, the teeth on this curve will change too. But I can delete this stuff, and the code is going to recreate it. In the rule version, if I delete this curve, I broke it. It doesn't work anymore, because the rule cannot create geometry, it can only define geometry. It can do the exact same evaluations, where it can do all kinds of measurements, and it can put it can create all kinds of geometry inside the code. It just won't put it in the tree, and it won't be accessible outside of the code unless it's defining geometry outside. I know that's really advanced information for right now, but for those of you that really dig into this, there might come a time when you want to get into it, and I think it's better for you to know that it exists now as kind of a carrot to aim for, rather than just kind of go along modeling thinking that that's all you can do here is just model. And in the next couple classes, we'll get into power copies, how to instantiate. We'll get into a little more writing code, how to automate instantiation, and that should lead into Grasshopper and a completely different way to achieve pretty similar stuff.
How'd you learn to write code?
I taught myself. I'll answer that. I'm going to stop the video now, and then I'll answer any questions.